As we begin adding the interactive doors to our level, I'm going to take a moment here to talk a little bit more about how the process might typically go in a studio setting for adding these kinds of doors. For example, we're going to be using the doors from Tim Van Can's course called Blueprints and Gameplay for Game Designers, but we're going to do some sort of additions and tweaks to it to suit kind of the gameplay intentions of our level design. So keep that in mind as we move forward here. One of the key collaborations in this project for this course is that we will be using the basic player interaction logic that Tim built into the player character in his course. We've taken it into our character for our course, even though it's a third-person action template project. We're going to use it, but there are some similarities and some differences. This kind of thing happens a lot in development, typically not in the core systems like this, but we've had to adapt it a little bit here for our needs. We're still using an input action, interact. We've mapped that out in the project settings. We're still using right here a trace to detect actors in range. We're checking hit results here, and we're checking the hit results for the BPI interaction. Again, we're using the same blueprint interface that Tim created for his project. We're using that, and we're using the same interact event, calling that same event here in the player character. The changes are we have to use some different coordinates for the start and end positions of the sphere trace. That's basically because there's camera differences between first person or third person games. Also, we're doing a different kind of trace here. We're tracing for objects this time. That means we have to create a special object in our project for interaction. And what we do for that is, if I go to project settings and I go under collision, this is a special collision we're setting up here. This is the new object channel that I've added for the sake of this project. It's named interaction. Its default response is to block. And I've created a new linked collision preset profile here. I've also called it interaction. By default, the collision is enabled. The object type is the same as the new object type, interaction. So that's just a quick overview so we can figure out how to use collision to drive player events in the actors. The next part of our level design collaboration involves including interactive door actors throughout the level, and we're going to be using the interactive door actors created by Tim Van Can for his course. We're going to make a few tweaks for additional functionality that we need for level design intentions in our course. So we have the parent class here, the BP door parent. We have the child class BPC door interface, which uses the interact interface that Tim made for his level as well. So we're going to use BP door parent and make some small changes to it. We need a few different things here. The door frame and door are fine for the visual representation of the door. We're going to use different things for the collision, though. We're not actually going to use the static mesh component collision for our interaction. Instead, we're going to be using the interact collision that we discussed earlier. So I'm going to add a box collision here, and I'm going to name this interact collision. If I go to the viewport, I'm just going to resize it up to roughly the dimensions of the door so that our sphere trace hits this when we try to interact with it. So we're going to add the proper collision settings for this. For collision presets, we go down to interaction. This will be how our line trace hits this and knows we want to interact with it. The reason we're doing two separate kinds of collision here is we're also going to include a sphere, and this will be a larger radius around the door that determines when the player gets in the middle of it. Let's just set this by typing in a property, 256 units. So the player gets within a certain space around the door, we'll actually unhide a text render component to mimic like what a UI would show us basically. I don't want to have these nested like that, so I'll just do that. Yeah, so next I'm going to add a text render component, and we'll just call this text render underscore UI, represent what we would have for UI. And this doesn't need to be so giant. We'll just make this centered horizontally, and we'll compile and save that. And for the sphere collision, we want to have the collision set up to be overlap all dynamic. That's fine. In fact, we could even make this overlap only pawn, because really all we care about is what happens when the player overlaps and gets near the door. And what it does is it actually will show this text render component. So we'll set this to hidden in game, because when the player's not in the radius, by default, we don't want any text on the door. And next, we're going to go to the event graph. We're going to add some events for when the player overlaps the sphere. And this is kind of similar to one of the other versions of the doors that Tim made in his course. We're just going to scroll down to the events category here in the details panel. We'll do on component begin overlap. And then we'll add another one to on component end overlap. And we set this to only detect the pawn. So we don't have to actually, we could, if we wanted to, if there's more actors in the game that are more complicated, we could actually check to see if this other actor that overlapped was the player. But we only have the player in our world, so, and they're the only pawn in the world, so we're not going to do that. So what we are going to do is we're going to get a reference to the text render UI, and we'll set this to, let's see, we'll do set hidden in game. So when the player overlaps the sphere, it shows the text render. So hidden is false. And then I'll just copy paste this function, and we'll set this to hide when the player ends overlapping this. This is a door. So I'm going to compile and save that. So by default, the text render UI will set it to open door. Let's just check to see where our text render component aligns. Looks like it's clipping the door frame, so we'll just move it out a little bit. And one thing you can do to offset your text layout here is if you hit return, you'll see nothing happens. I'm hitting return. If you hit shift return here, you can actually stack the text like that, if that's useful to you. I kind of like it. Makes it a little more succinct and easy to read. I'll compile and save that. Let's test our changes in the level here. So if we made changes to BP door parent, they should propagate to the child. So if we add the child here, and I added it to the level, and you can see that I currently had in the level browser blockout Milltown LD. That's our blockout level. So that's generally only for the level geo. We don't really want any scripted actors in there, any blueprinted stuff. So let's move this to Milltown LD, and I can just move selected actors to level and save each level that way. Or I can go to File, Save All Levels. That'll also do it. So let's just test this out really quickly. So I enter the outer sphere and it says open door. And then if I use my interaction, we see the line trace, sorry, the sphere trace actually hits that box collision we added to just check for interactive objects. So that was working as we wanted to. If we didn't do that with the inner box check, the sphere trace would hit the outer sphere of the door actor, and that's a little strange. Okay, so it's also strange that the open door is still showing. So let's see how we can tweak that so it's actually not showing when the door is open. Back in our event graph for BP door parent, we're going to need a Boolean to determine when the door is open or closed. So I'm going to add variable. I'm going to call it is open. And what we'll do is we'll only allow these overlap events to do anything when the door is closed. So we'll just do a check here. We'll add the is open variable, we'll do a branch. And only when is open is false will we allow this to work. So we'll just connect these to false. And we also need to hide this when the door opens. We don't want to see any text floating in the air when the door opens. So how can we do that? All right, we can go here to this timeline, and we're going to drag off of the direction node here on the door animation. We're going to do search for switch, and you'll see switch on E timeline direction. So that's an enum for determining when the timeline finishes in the forward or the reverse position. So when it's forward, that means the door is open. So we'll set the Boolean to is open. And then when it's backward, that means the door is closed. So is open is false. Another thing we'll do is we'll grab the text render UI and the set hidden in game. where it's hidden, we'll copy and we'll paste that here. So what it means is when this door actually opens, we will hide the UI. And when the door closes, we'll show the UI. I'll copy paste the node again and connect all of this. It's getting a little bit disorganized. And we'll comment this code here and we'll call it just UI. And we'll compile and save this. Let's test our new door. See if the functionality is working. Okay, there's open door. We interact with it and the text goes away and the text comes back and works as normal when the door is closed. So that seems okay. So let's look at where we can place this in the level. I'm also going to change some of the materials on the door so it matches with the level blockout geo, because sometimes during production, people can get confused about what's artwork and what's level design work in the level. So this has like finished materials on it. We want to make sure it's really clear that it uses developer materials. So I'm going to go ahead and apply the developer materials we use for our last course to this door. I'm just going to go with the dark gray material on the outer frame, and on the door itself, we don't want glass. We want this door to be opaque because that's sort of the sense of discovery we're using the door for. We don't want people to see through it. So we're going to make this just gray, our developer material gray. And then for the door frame, sorry, the solid part of the door, I guess I should say, we're just going to use regular gray. Actually, no, let's use white. There we go. So it gives it a little bit of obviousness when it comes to being part of the blockout. The last step we have to do to make sure this door meshes perfectly with our level blockout is make sure the scale's adapted correctly. Now, the scales for the doors as they exist, as they were when I imported them into this project, they used the dimensions that Tim Van Ken was using in his course for a first-person character. But we have this actual architectural scale in our blockout meshes, so we're going to do our best to make that match so that it still works as a playable level and fits the mechanics that we've sort of developed and are using for this project. So I'm going to place the door in the world there. I'm going to select the doorway mesh. I'm going to isolate these and select unlit mode so we can see them here. And let's look at this in wireframe. Okay, so we're going to drag this into position. Maybe I'll move it up a little bit. And it's a little bit tall, so I'm going to change the default scene root here in the instance. And then we'll go back and add the scale changes to the actual actor class in the content browser. So right now, let's see, we can set this to 1.15. That's pretty good. We don't want this to be all scaled in proportion to each other though. So here we want 1.5 and here we want 1.5 also. So if I look at this from the side view, we're going to sort of nest these door frames into our blockout geo, and that seems pretty good. So what we're going to do is I'm just going to grab, unhide everything. I'm going to right click here in the scale of the details panel and copy that and go to the BPC door interface here and go to this default scene root and then paste the scale values in there. Now we'll just do a quick test to make sure that the door works properly for our scale and looks properly, and it appears that it does. So we're good to place interactive doors throughout the level.